Now this problem says we have two parallel vertical metallic rails AB and CD. So there is a one vertical metallic rail AB, another vertical metallic rail we have CD. So there are two metal strips, they are kept in a vertical way and they are separated by 1 meter. So this distance, that is L, distance between these two are L basically, and this distance is given to you, that is 1 meter. So let us say I can call this as a L, and that is basically 1 meter. Are getting? Now the question says a horizontally metallic bar L of mass 0.2 kg slides without friction vertically downward the rail under the action of gravity. So this is moving in the downward direction, no friction. So mu is equals to 0 in this case. So mu is 0, that is given to you. And magnetic field is uniform. Let us say magnetic field in this whole region is inside and this is uniform. So magnetic field is uniform. Are you getting or not? And this magnetic field value is given to you, that is 0.6 Tesla. So B is given to you 0.6 Tesla. And the question says it is observed that when the terminal velocity is attained, the power dissipated in R1 and R2 are correspondingly this and this. So we have, there is a situation that is given. So problem says when terminal velocity is attained, so you are having terminal velocity. So at the point when the terminal velocity is attained, power in R1, this is equals to 0.76 watt, and the power in R2, that is also given to you, that is 1.2 watt. Are you getting or not? This is only when the terminal velocity is attained. We have to calculate, find the terminal velocity of R and R1, R2. So three things we have to calculate. What is the terminal velocity, what is the value of R1, and what is the value of R2. Are you getting or not? So three things we have to calculate. How we will proceed for this one? Now let us say, first let me make the diagram. So things are easy. So I have a resistance here, and the downward direction I again have a resistance, another resistance I have here, and these two are connected by another rail. So this rail is AB and this rail is CD. Let us say when the terminal velocity has been attained, this rod is moving in the downward direction with velocity V. Now if this is moving in the downward direction, if you see the flux on the top, what is happening? There is an increase in flux. If you go downward, so flux increases in this way. So by the Lenz's law, there will be current in this circuit. It will try to decrease the magnetic field because magnetic field gets increased, flux is getting increased. So you have to have something of this kind of current. Are you getting or not? You just fold your thumb in the direction of, you just fold your finger in the direction of arrow shown in the figure. You will find your thumb is going away from you, or you can say away from the computer screen. You check yourself. Let us assume this is the direction of current, and then you fold your fingers in the direction of arrow. You will find your thumb is going away from you. Then what? This will increase the flux. So this is not the right direction of current. But if you take something like this, in this case now the finger is coming out towards you. So if you fold the hand in the direction of arrow, you will find the finger is coming towards you. This means flux will decrease. There is an increase in flux in the downward direction. Now this means now I have to have current in this direction. Are you getting or not? Now what about the lower circuit? If you see the lower diagram, there is decrease in flux. So there is a decrease in flux. So by Lenz's laws, there should be flux current such a way so that there should be increase. Increase is possible only if I have a current in this way. Are you getting or not? So this means in this way I will have direction of current something like this. So let us say in this circuit current is I1. On the top circuit there is a current of I1 magnitude. So on the top circuit. Now in the bottom circuit you have a current of I2 magnitude. So this is I2. So what is the total current here? You will have I1 plus I2. Are you getting or not? So this EF or whatever, so this is a connector. Now I can write equation. What is the induced EMF across? Basically the direction of current can also be found using the EMF. So let us say this is your connector. If you see the connector, let us call this as a connector as EF. This is your connector. You see, this is your connector EF. Now if you see any positive charge, where it will move? So if this is moving in downward direction, your magnetic field is inside. So this is B, this is V. What is the direction of force? So Q V cross B. So V cross B will be something like this. So this is the direction of V cross B. Are you getting or not? This means positive charge will land up here and negative charge will land up here. Are you getting? So this means now I can replace this circuit with a simple circuit, simple diagram. I have a resistance and then I have a battery, positive terminal this side, and then I will having something like this, and then I will have another resistance R2. Are you getting on? So this is another resistance R2. So this is R1, this is R2, and this is basically battery Xi. What is Xi? We can calculate this is Xi is simply BLV, because this is moving with a terminal velocity BLV, and for me this L is capital L. So this is Xi is equals to BLV. Now let us try to see I can solve this equation. So in this circuit I have current I1, and in the bottom circuit I have in current I2. So total current is basically here I will have I1 plus I2. Now I can write circuit equation to solve I1 and I2. Basically we have been given power delivered in R1 and R2. So if you write equation in the top circuit, I will write this is Xi, or I can write Xi minus IR, or Xi is equals to, so Xi is equals to, so this is equals to I times R1. Are you getting or not? So circuit is equals to current times R1. Current is I1, so this is I1 times R1. Now similarly for the second you can write equation Xi is equals to I times R2, I2 times Xi is equals to I2 times R2. I will also have one equation, what are the forces, that is the terminal velocity you have. So we can get the next equation using the terminal velocity. So this rod, what are the forces acting on this rod? So there is a force mg that is acting in the downward direction, and another force that will act in the upward direction, that is F I delta L cross B. So this is the direction of I. Then basically this is the direction of delta L, and B is inside. So you have this is the direction of delta L and B is inside. So delta L cross B is upside. So this is your delta L cross B. So you will have a force ILB in the upward direction, that is I in this circuit is I1 plus I2. So this is I1 plus I2 and length is L and the magnetic field is B. So we can solve another equation. Total force is 0 because this is moving with a constant velocity. Terminal velocity, this means velocity is constant. If the velocity is constant, acceleration has to be 0. So mg is basically equals to I1 plus I2 into L into B. So this is my third equation. Now we have to solve for I1, I2. Oh, another equation is given, power in terms of power. So power dissipated in R1, that is I1 square into R1, and the power dissipated in R2, that is I2 square into R2, and these two values are given to you. So you check the question. This says one is 0.76, another is 1.2. So one is 0.76, another is I think 1.2 watt. So we can basically calculate from here R1, R2. Are you getting or not? Let us try to solve. If I add this to equation, what I will have? Now this is total solving, so I will have I1 square R1 plus I2 square R2, and this is equals to 1.96. 1.96. Are you getting or not? So if I add, now I1 square into R1, that is here I1 square. So if I multiply by I1 both sides, so this is xi times I1. Are you getting or not? So if I multiply this equation by I1 and this equation by I2, so I1 square into R1 is nothing but xi times I1. So this is xi times I1 and this is xi times I2. Are you getting or not? And this sum is 1.96. And xi times I1 plus xi I1 plus I2, that is mg by lb. So now I can write xi, and I1 plus I2 is nothing but mg divided by L into V. Are you getting or not? This is mg divided by L into V. So this is equals to 1.96. So now I can calculate xi from here. So what is xi? So xi is basically equals to 1.96 divided by mg, and the lb I will have on the top. You're getting? Let us plug all this value. I can calculate xi in this DMF. 1.96. What is L? So you check. So length is basically, let me see. So this is 1 meter separated by 1 meter. So L is 1 meter and B is 0.6. So length is 1 meter and B is 0.6. And what is mass? I think mass is 0.6. Let me check. This mass is basically 0.2 kg. So mass is 0.2 kg. So 0.2. And I am taking this Z value is 10. Gravity value is 10. Are you getting? Okay, let me use my calculator to calculate this value. So this is 1.96. So I will have 1.96 multiplied by 0.6 multiplied by 0.6, and this divided by R2, simply 2, because 0.2 into 10, so this is 2. So what is this value? So this is 0.588. So this xi is 0.588. So let me write this value. So this is xi is 0.588 volt. What would happen if I have taken 10 in place of 10? So let us try to take z is equals to 9.8. So if I take this value, what will be the xi? So let me check, because the answer is not coming as a whole number. So what I have to do is I have to simply 0.588 and this divided by 0.2 or divided by 10 and multiplied by 9.8. So this divided by 10 and multiplied by, so this is equals to this and multiplied by 9.8. So this multiplied by 9.8, 9.8. So this value comes out to be 0.5762. I think I have done some mistake. I have to divide by 9.8. Are you getting or not? So let me check again. So this is basically 0.588 multiplied by 10 and this divided by 9.8. Now things are easy. Okay. So this value, this is 0.6. So this is a whole number. It's a good number. So now I know this value is 0.6. So if I take z is equals to 9.8, xi is 0.6. So let us say xi is 0.6 volt. And this is only if I take if I take z is equals to 9.8. Are you getting or not? Now I can calculate everything R1, R2. So if I plug this value, I can calculate R1 and R2. You see, you have this equation. You know the xi, you can calculate I1, I2. I1, I2, you can calculate from here. Are you getting or not? So you know I1 plus I2. From where I will calculate I1, I2. From this equation I can calculate. You see, I1 square into R1 is 0.76. So let us say I1 square into R1, that is 0.76. And now I know that is I1 into R1 is xi. So xi times I1, that is again power, I can write xi times I1. So this is again the power equation, 0.76. So this means I1 is what? 0.76 divided by 0.6. So this will be, so 0.76 divided by 0.6, we can again use my calculator. So this is 0.76 and divided by 6. So this value 0.1266, 0.1266. So this is I1 is 0.1266. This is in ampere. So now I can calculate R1. Are you getting or not? So you see, what is R1? Xi is equals to I1 times R1. So xi by I1 is equals to R1. So R1 is xi divided by I1. And xi I know, that is basically 0.6 volt. And I1 is 0.1266. So this is 0.6 divided by, so this is 0.6 and divided by 0.126 is 0.1266. So this value comes out to 4.73. You're getting? Basically this is wrong. This should be 1. So this is 1.266. Now if this is 1.266, so basically this means I have to replace this decimal here. So this decimal should be placed here. Are you getting? So you have to have a decimal here. So this means now this answer, that is 4.73, will have 0.473. So this is 0.473 ampere. This is ohm. Similarly, you can calculate R2. Are you getting or not? So this is a quite good program. One important point we have to find out the direction of current. So this question illustrates Lenz's law. So if you know the Lenz law, that's fine. Are you getting or not?